talking about Lasair. So.
Thank you all for being here. I understand coffee break is next. I'd like to thank Matthew Graham, if he's still here, for reminding us that it's been 20 years since we started thinking about the deluge of events, and or at least it will be when it actually starts. Lasair is our broker, which is Edinburgh and Belfast and Oxford. And it's designed to have an easy on-ramp so that it's easy for an astronomer to get started. You know, if, for example, you're interested in some kind of object, you know, Amcan Vens or something like that, and you know who they all are, where they all are, you can just ask, tell me when any of my guys has an outburst. You can ask very simple questions. So we've tried to make the on-ramp easy, but we've also tried to make things competent. Now, speaking of competent, does this thing do, there we go. Let's see, we had a few joules in the last month or so. We've had a couple of rather fast TDEs that we found since Christmas with Matt Nichol and his collaborators in Belfast. We've had some new fresh kilonovas from Michael Fulton and his scheme, which I'll explain. And there are some these white dwarf mergers and calcium-rich supernovae, and all sorts of interesting things are happening. What Lasair does is to find the joules. It doesn't just sort of produce huge stamp collections of supernovae. It produces the joules, the things you actually want. Recently, ZTF has been putting force photometry in with their stream, and the reason for that is that when you see a single 5 sigma alert in the actual stream, you can ask for force photometry, what was it before, and that gives you a handle on the rise time. And so you can detect these very fast rises. So now we have that available through Lasair. You know, I was at the Lego store in Edinburgh the other day, and I realized that when I was a boy, we used Lego in a different way. These days, it's as if people buy these kits that make something up for you, that you pick one of the classifiers that's already been built, and then you can, you know, get the results from it. But with Lasair, it's more like a whole set of bricks, and you just sort of put them all together in whatever way you want. We've used SQL as the glue between our bricks, that ever since the Sloan survey, astronomers have become used to using SQL. And so we thought this was a good channel to bring them on board. And once you've built your SQL query, you can share it with other people. You can use it as a springboard for more complicated analyses and annotations. So the bricks are light curve features, sky context, watch lists, watch maps, which is like a gravitational wave sky map, the transient name server, and the annotations that you yourself and other people have produced. Okay, this is a bit nerdy, isn't it? There's some actual SQL up here. See where it says objects.gmag and objects.jdmax, the latest Julian day as latest detection, and you want the Gmag to be not null, and you want it to be less than 15. So this is a way to filter out if you want bright things. It's a very simple way of getting bright things. And there's all sorts of other stuff. There's the schema browser. You can save these queries. You can share these filters. We're supposed to call them filters. You can share them and save them and all of that kind of stuff. So once you've made a filter, of course, you can click on it, We also have a very competent API through which you can run the query. So that's where the human says, okay, give me the results of the query. But you can also say, I want this as a streaming query. And that means that as the data comes in, it runs your filter and immediately notifies you. You can get results for the 20th century people, you can get email, and for the 21st century people, you can get Kafka. And we have a Marshall notebook connected up to the other end of the Kafka so that you can go through what's happened and decide whether you like it or not, and so on and so forth. And right at the bottom here, you see it says public if you want to allow other people to see your filter. Other people can then duplicate that filter and modify it in ways that they wish to. A watch map is, well, thank you to the taxpayers of France for funding the MOC project, these wonderful files that express a subset of the sky. And these, you can upload one of these MOC files. On the left, you see the Sloan footprint, which is, if you want to get alerts that fall within the Sloan footprint. On the right is the real reason for this functionality, which is to do sky maps. And we're about to release our system for dealing with gravitational wave alerts. We also have an intelligent sky context system called SQL-like that's been developed in Belfast over many years. And given a position in the sky, it tells you what's there. It picks from a number of these catalogs that you can read, you know, the CVs and the AGNs and all the rest of it, and does an intelligent classification. I won't go into the details of what that means, and it makes a classification from those that you see on the right. So when it says supernova, it actually means that there's a host galaxy, and when it says nuclear transient, it means that the transient is close to the center of a host galaxy. And you can see the little smoking pipe up at the top, which probably not very woke these days, is it? A tobacco pipe. Anyway, that's the SQL-like symbol. We've built a number of light curves of light curve features in addition to what Ruben has provided already. Ruben has done a great job with periodic features and stochastic features, and we've tried to look at light curves where you don't have very many points. And one, for example, is the flux jump. That's this guy who says, I want to know when one of my sources suddenly gets bright. What they can do is just monitor the flux jump. Over on the right, there's this idea of we have 6 filters instead of 6 filters with LSST, whereas we only had 2 with ZTF. And so maybe we can think of a surface of time and wavelength rather than treating the filters independently. And you know, here you can see trying to fit exponentials, trying to fit Bayesian multiplied by a black body in wavelength. So it's a 2D fit, and let's see which of them does the best job. Let's see, here's how to find tidal disruption events with Lasair. This is a bit of SQL. Is that okay to show a bit of actual code? It's all right, isn't it? So first you ask SQL-like, does it have a host galaxy? And that's this second line. The classification is in either supernova or nuclear transient. And you ask for the separation in arc seconds to be less than half an arc second. The third line is about, we want more than 2 points in the light curve, and then G minus R, the color, and then we want things brighter than 20th magnitude, and we want something which is away from the Milky Way, the galactic latitude. Then we combine that SQL on the light curve with this watch list. In this case, There's a paper by these people, French and Zablukov, saying that they think these 55,000 galaxies are especially liable to have nuclear transients. And so you combine the SQL with the watch list, and out pops the TDEs. Annotation is where the Kafka stream from a pre-filter goes into your own code that runs on your own computer, and it does some computations on the light curve or other aspects, and then pushes that back into the Lasair system. And so one of them, for example, is Fast Finder, which is made to find fast rising sources, and it produces a piece of JSON as its output, such as that shown. Here's the workflow. You would have an active filter, one of these streaming filters, which you see at the top in purple, and then that goes over to your own machine, which does the processing and light curves and stuff, and then makes a decision about whether to annotate or not and pushes it back into Lasair. So here's that cycle where you have a pre-filter at the top left, then there's this fitting by the Fast Finder system, which then causes a Lasair annotation, a discussion on Slack, and then off to Gemini to get a spectrum. We've also sort of rather naughtily stolen stuff. Oh, no, no. We have, with permission, taken Kafka feeds from Lasair and Fink. And so you could, for example, use different systems to find kilonova and say, I only want the ones where FastFinder thinks it's a kilonova and Fink thinks it's a kilonova. So let's hope we can do more working together in this kind of way. Okay, so this is it. As we heard yesterday, I like this quote: LSST variability greatly exceeds the parameter space of training sets, from Richard Anderson. Is he here? Yes, thank you. Thank you for that. And that's why we've gone with this approach of computing features, because that's an unbiased way of characterizing a light curve, rather than building the classifiers, which sort of tells you what you might expect to get before you've actually seen the stuff. So please give it a try, lasair.lsst.ac.uk, and are there any questions?